Good morning and welcome to today's lesson on stress and strain. Just to do a brief introduction on stress and strain, any engineering material under a load, stress must be induced and as well strain. Let us start by defining what stress is. Stress is defined as the force per unit area offered by a body against deformation. We can express stress mathematically as P over A, where this is the symbol for stress, given by P over A, where P is the external force applied on the body and A is the cross-sectional area of the body under the load. The units for stress depend on the unit load or force and unit of area. However, the SI units of force is expressed as in newtons and the area in square meters. Hence, the unit for stress becomes newtons per square meter. There are three types of stresses. One, tensile stress, which is caused by two equal opposite pulling forces. Compressive stress, which is caused by two equal and opposite pushing forces. And finally, shear stress, which is due to two unequal and opposite forces acting tangentially across the resisting section of the body. Let's go to strain. Strain can be defined as the ratio of change of dimension of a body to the original dimension due to application of an external force. For instance, if you apply a tensile force on a body, the body will be pulled at the ends and its length will increase. So to get the strain for such a case, you'll take the difference in the length, that is the original length, subtracted from the new length over the original length, then times 100 if you want to give it in percentage, or you give it as a ratio. Then there are three types of strains: tensile strain, which is caused by tensile stresses; compressive strain, caused by compressive stresses; and volumetric strain, which is strain as a result of change of volume in a body. And because strain is a ratio, it has got no units. You just give it a number. We can look at this diagrammatic summary, summarizing stress and strain. In the first diagram, you can see a body which is pulled on the side by two equal forces in opposite directions. This is the tensile force, which will produce tensile stress and again tensile strain. The second diagram, you can see two forces which are pushing forces, and this is what results to compressive stress and eventually compressive strain. Then in that diagram, you can see this is a shear stress. Two unequal forces acting tangentially on the body under the load, resulting to shear forces. You can see this is the result of applying shear stress on a body. This is what we call shear. So generally, this summarizes what stress and strain is in any engineering material under a load, whether tensile load or force, compressive load, or a shear load. So it is very important to note that stress and strain are important when you are talking about engineering materials, that is specifically their strength, because different engineering materials will have different strengths depending on the stress they can handle when a load is applied on them. Again, on strain, different engineering materials will have different strains depending on the amount of load applied on them. So you cannot talk about strength of materials and forget about stress and strain. They must be talked about. So I think that is a good diagrammatic presentation for stress and strain. So thank you for listening and good day ahead.